Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture, let us see about Thevenin's theorem. So Thevenin's theorem is as follows. Any linear two-terminal bilateral active network can be replaced by a voltage source which is represented by Thevenin's voltage in series with a resistance known as the Thevenin's resistance. So Thevenin is nothing but the open circuit voltage across the terminal, and Thevenin is the equivalent resistance looking back from the terminals. So this is a Thevenin's equivalent circuit. So as shown here, a complex network will be replaced by a voltage source in series with a resistance, and you will be connecting the load resistance as shown here. So first we will see the steps for solving the problems using Thevenin's theorem. So first one, we will be considering the circuit diagram by circuiting the terminals with respect to which the Thevenin's equivalent circuit is to be found. So the point AB, that is the load resistor, has to be open circuited, and we will be seeing the Thevenin's voltage across the open terminals of the circuit. Next one is we have to find out the Thevenin. So to find the Thevenin, we will be short circuiting the voltage source or the open circuiting the current source, and then we will be finding Thevenin from the point AB or from the load resistance. We will be looking back the resistance which is known as Thevenin. Then we will be drawing the Thevenin's equivalent circuit by having a voltage source Thevenin in series with the resistance Thevenin. So we will see an example. So in the circuit shown, find Vx by first finding Thevenin and Thevenin. So first step is we have to remove the resistance, which is a 2 ohm resistance, that is across, which is connected across AB. So the circuit will be like this. So next we have to find out Thevenin. So Thevenin, that is voltage across AB, can be found using the voltage division rule here. So the total voltage into corresponding resistance divided by sum of the resistance. So voltage across AB is nothing but voltage across the 6 ohm resistance. So we can find out voltage across the 6 ohm resistance using voltage division rule. So 30 into 6 divided by 6 plus 12. So you will be getting 10 volts. So your Thevenin voltage is equal to 10 volts. Next we have to find out Thevenin. So to find Thevenin, since you have a voltage source, you are short circuiting the voltage source. If you have a current source, you have to open circuit the current source. So we have to see back the resistance from the point AB. So when you look back from AB, you know that 6 and 12 ohms are in parallel, which is in turn series with 4 ohm resistance. So 12 in parallel with 6 plus 4. So you can calculate the equivalent resistance as follows. So 12 into 6 divided by 12 plus 6 will give you the parallel equivalent resistance, and then you will be adding the answer with 4 ohms. So you will be getting as 8 ohms. So this is your Thevenin's equivalent circuit. So Thevenin is 10 volts, which is drawn in series with the Thevenin 8 ohms, and then you are connecting the load resistor 2 ohms here. So in order to find the voltage across the load resistor, we can use V is equal to, you can use here 10 into 2 divided by 2 plus 8. So you will be getting it as 2 ohms. So we will see another example. So in this example, we have to find out Thevenin, Thevenin, and also load current flowing through and load voltage across the load resistor using Thevenin's theorem. So the first step here is to remove the load resistor RL and keep it as open circuit. So we are removing it as shown in the first figure. And then you have to calculate the voltage across AB, which is your Thevenin voltage. So voltage across AB is nothing but voltage across 4 ohms, 4 kilo ohms. So you can find it using voltage division rule. That is 48 volts into corresponding resistance 4K divided by sum of the resistance 12 plus 4. So you will be getting it as 12 volts, or else you can find out the current through the first loop, and then you can write it as V is equal to I into R. So here current is calculated by I is equal to V by R. So 48 divided by 12 plus 4, which is 16. So 48 by 16 will give you 3 milliamps. So current through 4 ohm kilo ohm resistor is 3 milliamps. So 3 into 4 kilo ohms, you will be getting 12 volts. So either you can use voltage division rule, or you can calculate current, and from the current you can calculate the voltage across 4 kilo ohms. So this is your V Thevenin voltage, which is 12 volts. Next we have to find out the R Thevenin. So in order to find out R Thevenin, the 48 volts voltage source is short circuited, and we are looking back the resistance from AB. So here again 4 and 12 volts are in parallel, which is in series with 8 kilo ohms. So you will be getting R Thevenin is equal to 11 kilo ohms. So this is the equivalent circuit. So now we want to find out the current through road resistor. So I is equal to V by R. So 12 by, here R is 11K in series with 5K. So 12 divided by 11 plus 5. So you will be getting 12 by 16 kilo ohms, which is 0.75 milliamps. So next we have to find out the voltage across RL, so which is equal to current across RL into resistance RL. So current is 0.75 milliamps. So 0.75 in milliamps into 5K. So you will be getting it as 3.75 volts. So this is how you will be finding out the Thevenin's equivalent circuit. So once again I will repeat. First we have to open circuit the load resistance. We have to calculate the Thevenin's voltage. Then for finding out the equivalent resistance or Thevenin's resistance, we can short circuit the voltage source or open circuit the current source, and then we will be calculating the equivalent resistance looking back from the open terminal. Then we will be drawing the equivalent circuit. So we will see some of the applications. So Thevenin's theorem is used in the analysis of power systems. So it's also used in source modeling and resistance measurement using the Wheatstone bridge. So there are some limitations. It is used only for linear circuits like superposition theorem, and the power dissipation of the Thevenin equivalent is not identical to the power dissipation of the real systems. Hope you understood Thevenin's theorem. Let us take some assessment questions. So what is Thevenin's theorem? The Thevenin's theorem states that it is possible to simplify any linear network irrespective of how complex it is to an equivalent circuit which consists of a single voltage source in series with a resistance. So it's converting a complex circuit into a simple circuit. Next one is, what is Thevenin's voltage? So the open circuit voltage that appears across the two terminals is the Thevenin's voltage. Where is Thevenin's theorem used? It is used in the analysis of power systems. Thank you for watching this video.